All right, so this is our unit for triangle. We're talking about congruence and similarity. So our first lesson for today is really going to be over definitions, and then we're going to talk about the triangle sum theorem. So I'm going to do a little bit of vocabulary review with you first. So let's talk about some vocabulary terms. The first vocabulary term that we have is the word angle. And we know that an angle is formed by two connecting rays that share the same endpoint. Two connecting rays that have the same input. I'm trying to get my pen to work for us. There we go. Two connecting rays. Okay. So an example. This is BA. So this could be called ray BA and BC, ray BC. The vertex is actually at point B, and this is angle ABC. We call this angle ABC. When we name an angle, we make sure that the vertex is in the middle. So a vertex is just that. It's a common endpoint shared by two rays for an angle. Acute angles measure less than 90 degrees. So an acute angle could be something like this. And when we talk about an angle measure, we're referring to this little arc that I have in the inside, and I'm going to call this X. I'm just going to call it measure X, and I'm going to say that 0 is less than X is less than 90. That just means that the measure of an acute angle is in between 0 and 90. A right angle measures exactly 90 degrees, and we show that we have a right angle by this mark right here on the inside, this little box. That means that it's exactly 90 degrees. An obtuse angle, well, that just means that the measures are between 90 and 180. So if I were to call this Y, 90 is less than Y is less than 180. And then an angle that measures exactly 180 degrees is called a straight angle. So that's something that looks like two rays. There's my vertex, but this is 180 degrees. Okay. All right. So now let's talk about some types of angles, like congruent angles. Congruent angles are just angles with the same measure, same degree. An angle bisector is a ray that splits an angle into two congruent equal measure pieces. So this symbol right here means congruent. All right. Adjacent angles are two angles that lie in the same plane, have a common vertex, and a common side. So let's look at a pair of adjacent angles. Adjacent angles could be something like this. So this is angle A, B, C, D. So I have two angles. My first angle is angle A, B, C, and my second angle is angle C, B, D. So they both have vertex. They both share vertex B, right? They share that. And then their common side is ray BC. That's the common side. or the shared side. And just so you know, this is how we identify a ray, or that's how we name a ray. Vertical angles are two non-adjacent angles. So I'm going to draw a picture of vertical angles right here. They're formed by intersecting lines. Two intersecting lines. So there's something that we know about vertical angles. When we have vertical angles, the opposite angles have the same measure. The opposite angles have the same measure. Okay, so opposite angles are congruent to each other. A linear pair is a pair of adjacent. Remember, adjacent means they have the same vertex and a common side. So an example of a linear pair, something like this, where maybe this is 30 degrees and this is 150 degrees. So a linear pair, it's called a linear pair because of the word line. The angles sum up to 180 degrees. That's why I chose 30 degrees and 150. Complementary angles are two angles whose sum is 90 degrees. An example of complementary angles could be something like this, 25 and 55. Well, how about 25 and 65? 25 degrees and 65 degrees. And then supplementary angles are two angles whose sum is 180 degrees, much like a linear pair. The only difference is that supplementary angles don't have to touch. For example, I could say this is 88 degrees, and I could pair it up with another angle that is 92 degrees. And I could say that these two angles are supplements of each other. If I were to add them together, I get 180. Okay. So now we're going to do kind of an activity. So I have green triangles. I have green triangles up front. Please make sure that you grab a green triangle. And the first thing that you're going to do is you're going to number your corners or your vertices on your triangle. Now, this is just a little activity, and I want you to tear your triangle. I want you to rip your triangle. So I'm going to go ahead and do this activity with you while I am drawing it out on the board. So I'm going to number my triangle sides 1, 2, and 3. And I'm not numbering the sides, actually. I'm numbering the angles. And then I'm going to just rip those. I'm going to rip all of the angles off. Ripping all of the angles off. I don't care about that middle piece. When I rip all of my angles off, I had this middle piece right here. I'm just going to throw it away because I just really want you to see that when I take my angles and I line them up, angle 1, angle 2. So I want to show you what it looks like. When I line mine up, I have like angle 1. Mine was really narrow right here. This was angle 1. And then my angle 2 is right here. And then my angle 3 is actually upside down when I put it in there. So it looks like an E. Looks like an E, but it's not. That's my angle 3. So the goal is for you to realize that the sum of the interior angles, so we just took all of our triangle and ripped it apart. And when we add them back together, laying them sideways like this, we see that the sum of the interior angles makes a straight line. And we know that a straight angle is 180 degrees. So in this activity, we've just proved that the sum of the angles, and this is the interior angles, right? The sum of the interior angles, the inside angles of a triangle is 180 degrees. In mathematics, when something is proven, it is called a theorem. So we have actually just proven the triangle sum theorem. All right, so now you can take your little triangle pieces and you can throw those away. I'm going to actually tape mine together and hang it on the board as like a reference for you so you can see it. So what does that mean? Well, that means that if I have a triangle, like in example 1, that has a missing angle that I'm trying to find, I can actually just add them all up. 75 plus 55 plus x, and know that they have to equal 180. 75 plus 55, that's 130, plus x equals 180. I subtract 130 from both sides, and x equals 50. That means that this angle right here is 50 degrees. Two angles of a triangle, so I'm going to draw a picture that helps my brain. Two angles of a triangle have measures of 30 degrees and 55 degrees. I have to find the measure of the third. So 55 plus 30 plus y equals 180. 85 plus y equals 180. And when I subtract 85 from both sides, I find out that y is 95. So this angle right here is 95 degrees. So that's kind of the idea behind the lesson today. That's the idea behind the lesson. Now I'm going to go ahead and go on to page 4, and I'm going to do a couple examples from each one of these, but I'm not going to do all of them. Okay. So I'm going to start with this first example right here. So this top right example, and I'm just going to identify some things. This is a pair of intersecting lines, and they create vertical angles. And I told you that vertical angles make, when I have vertical angles, the opposite, or two intersecting lines, the opposite angles are congruent. So if this has a measure of 35, then this has a measure of 35. Okay. Well, now I have a triangle right here, and I am looking for this measure. I'm going to call it x. So 35 plus 100 plus x equals 180. Well, that's 135 plus x equals 180. When I subtract 135 from both sides, I find out that x equals 45. So this angle right here is 45 degrees. But now I want you to see that I have a linear pair right here. So this angle that I don't know plus the 45 have to also equal 180. So the angle that I don't know, I'm going to call it y, plus the 45 degrees has to equal 180. Subtract 45 from both sides, and I find out that angle y has a measure of 135 degrees. Okay. Let's go to this example right here. Notice this. This means that this is 90 degrees. So I have 180 equals 90 plus 40 plus x. 180 equals 130 plus x. When I subtract 130 from both sides, I find out that x equals 50 degrees. Okay. All right, I'm going to jump down to part 2. Again, I will do the rest of these on Wednesday. I just want to give you a baseline. So the sum of all of the interior angles adds up to 180. So 55 plus 54 plus x plus 74 equals 180. Well, 55 plus 54 plus 74, that's x equals 183. x plus 183 equals 180. When I subtract 183 from both sides, I find out that x equals negative 3. Now, it's not telling me that an angle has a measure of negative 3. It's saying that the value of x is negative 3. So this angle up here, let's see, negative 3 plus 74 is 71 degrees. Does that make sense? Okay, we're going to do much like that again. We're trying to find the measure of angle A. That's this angle right here. So x plus 59 plus x plus 51 plus 84 equals 180. Let's see, 50 and 50 is 100 plus 10, 110, 194. So I have 2x plus 194 equals 180. When I subtract 194 from both sides, 2x equals negative 14. Divide both sides by 2, and I find out x equals negative 7. Again, it's not saying that the angle measure is negative 7. It's saying the value of x is negative 7. Negative 7 plus 51 equals the measure of angle A. Well, negative 7 plus 51 is 44. So 44 degrees equals the measure of angle A. All right, so you have just finished your test. I know that. You just finished your test. So once you watch this video and you fill out your notes, you're going to have page 2, page 3, examples 1 and 2. You'll have your fabulous little green triangle, and then you'll have 4 other triangles that I have worked out for you. 4 other triangles that I've worked out for you. Your homework for tonight is a Delta Math assignment. It is called Triangle Sum Theorem, and it's linked for you in the module. And I think maybe I'm just going to go to the module and show you if I can get into Canvas without a big, not going to show you because I don't want you to see my code. So yeah, if you go to the module, you're going to see that you have your assignment in Canvas.